Welcome back, dear friends. Thank you very much for all your interest in my previous video on how to turn an eBay analog meter into an illuminated one that can display barometric pressure or a range of other items. More views than I've ever had, so that's great. And in a follow-up to that video, I'm going to show you today how to design a gauge legend or a meter index, or the label that goes on the meter, whatever you want to call it. I prefer legend because it sounds amazing. A number of people said they tried using AutoCAD or other software and just kept getting stuck. Now I use my lovely old 2D design software, which I first started using in the early 90s, because it was the CAD software that was installed in all secondary schools in the UK. And it hasn't changed much since then. This is version 2, 35 years later. It's got basic tools, but as someone who learnt about engineering drawing at Central School of Art and Design in the 80s, sitting in front of a huge AO drawing board with a massive sheet of tracing paper and pencils, rulers and a horizontal motion, and drawing everything, you just have to calculate all the spacings between the each view of the orthographic projection before you even started, because if you made a mistake you were stuffed and you had to start again. I mean, it really did focus your thoughts, and I'm amazed at what human inventors and engineers achieved without any computer-aided design. Just early on with slide rules, we had calculators thankfully, but just all that. And then once you'd drawn it all out in pencil, then once it'd been checked, you'd have to go over it all with a little rotaring pen or a variety of them to get the line thicknesses right. Then it could be copied using, you know, the blueprints or whatever that used to smell of methylated spirits. What a joy. Anyway, I digress yet again. So I use this 2D software to design all the dials that I've done. So everything from clock faces with associated cutouts, to quite complicated revolving readouts, to clock faces that don't go all the way round, seemed like a good idea at the time, to the meter that we looked at last week. So I'm going to show you how I do it with basic tools, so hopefully the skills will be transferable onto whatever software you want to use. So here's the work window. You've got some tools down the left hand side, drawing tools. You've got some sort of arrangement tools down the right or something in the piece of paper. So the first thing we need to do is to measure the diameter of the legend. That is 61 millimeters. Half of 61, because this software only allows you to input radii. We click on that, we can select that tool. 30.5. And we can draw a circle. Now I'm going to zoom in. Now the next thing we need to do is to work out the size of the rectangle that we're going to cut out of the bottom. That is 24.5 wide. So what we're going to do is we're going to draw a square, and we don't care about the height of it, but we need the width to be 24.5. The height could be, say, 40. I don't care. We don't care where it's going to put it either, because we're going to move that roughly into place there. Then we want to work out, well, how high do we want that to be? So we're going to measure the distance between the top of that rectangle and the top of the gauge, which is 42 millimeters. So a centre line is very handy. I studied technical drawing at school, which was an absolute joy, because we learnt how to construct all sorts of different geometric shapes simply with a ruler and a pair of compasses. It was amazing. So I've drawn a vertical line there. I'll try and stay on focus. I'm going to centre it like so, and I'm going to draw a circle 42.5. We've got the 0.5, 42.5. And now I'm going to switch that off, switch this on. This allows you to construction points, nearest point, centre point. That'll do. Allows you to locate things very accurately. The cursor turns to a little dot. I'm going to put that there. Now you see I now know that that is 42.5 up. Drawing it with a circle, I can't, there we are, it's that one. means that if that wasn't quite in the centre or something, it would always tell you, if that makes any sense. Now what I need to do, I need to make sure that's in the centre. I've got that line now, it is. Then I'm going to click on this tool, which allows me to move what I've selected. I want to move it from there to there. There you go. I don't need that anymore. I'm going to delete that. So we've started drawing something. Now I'm going to use this tool, which is one of my personal favourites, which is the delete between lines. Oh, it is just such a joy. Oh, when you think if you're doing it on tracing paper, you'd have to have a little guard, an eraser guard, thin stainless steel thing. You'd have to move it just where you want it and just use a little rubber to rub away the bits. This is just a joy. So now we need to put some radiuses in. I used to use my lovely circle template that I'd had since I was at college, but my son borrowed it and it disappeared, so I'm going to have to guess with a ruler. 2.5 millimeters each. So luckily there is a radius tool which is there. So the radius was 2.5 millimeters. Here we are. That's nice. And the radii on the bottom here are also 2.5, and I'm going to use a different tool. This is one of my favourite tools. Make that 2.5. It will draw a radius between any sort of line or curve. It's one of the tools that I use most to design all the funny steampunk shapes. Right, so we've got that. Now we need to work out the semicircle, which goes, so that is 5 millimeters up, and the width of that semicircle is 14. So put that there, make that 14 wide by 5 high. And we can put that in the centre. We now know that we need a circle, part of it, that's going to go through those 3 points. And there is a tool. 1, 2, 3. Isn't that lovely? And delete that, and delete that and that. So the next part of this, the final part of the structure, you'll be pleased to hear, are the 2 screw holes, which obviously are very important. So we're going to measure the height they are from this point, and it's 2.5. So let's get another one of these, and we're going to make it, I don't know, 30 by 2.5. There we are. So that's going to give us the top line, the height of each of those 2 holes, and they are 30 millimeters apart. So we could do what we said earlier. We could say, okay, half of 30 is 15. I'm good at that, I can do that. Put that there, and then each of the holes is 2.5. What's half of 2.5? This is where my maths falls down. 1.75, something like that, I think. Quite possibly wrong. So we know that one's there and the other is there. Right, onwards and upwards. So we don't need that, and we don't need that. Now it's time to start thinking about the graphics that we want to design on the dial. In order to do that, we need to know where the centre of the moving core movement actually is, e.g. the point about which the pointer moves. We can do that in a couple of ways. One is to use a ruler and actually measure it on the gauge before you take it to pieces. Alternatively, you could scan in the existing dial and put that onto your CAD software and take measurements off that. I'll show you how to do that later in the video towards the end. You can find in the list of chapters where it is if you want to go there straight away. Now I happen to know with this meter, but you'd have to work it out yourself, that, let's go to here, radius, it's the centre of this circle here. There we are. So there, that's given us the point now where we can construct all these arcs and things. So the first arc, that's the inner one, is going to be 24 millimeters up from that point. So just for argument's sake, let's put that there and go, I don't know, 10, 24. Well, so that's the first one. These two lines are 2.5 millimeters apart, so let's just go to 2.5 by whatever. I do apologise if this is painful to watch, but this is how I do it. And then the lower parts of the engraving are 2 millimeters below that. So that is going to be, oops, 2 and -2. It works for me though. Now we can use a different tool which just asks you for where you want the centre of the circle and where you want the end. So we can draw one to there, we can draw one to there, we can draw one to there. Then we don't need these anymore, so let's get rid of those. And we'll keep that. In fact, let's be a bit clever. Let's just put some sort of little mark or something there, so we don't have to have this huge radius sign. Dimensioning radii is just a handy way to find the centre of a circle. That'll do. We can even slide it across a bit. Now I don't need all these pieces around the edge, so let's just use the lovely tool, mainly just because it's fun. Fun is good, to delete them. So the next thing is to work out how far the pointer moves, the sort of full scale deflection, the length or whatever, the arc length or something of that gauge. So that's 14.5 from here to the bottom of there. So let's draw that. So we're going to go 40, well it's just 50 by 14.5. Now I'm sure there are cleverer ways of doing this, and I again apologise profusely, but it works. So we now know that this point, we might measure to the centre, the middle line, there we are, we now know that's where the pointer's maximum and minimum position is. So we can delete that, because now we can start drawing lines and lines and lines. We'll start them off in the centre and we'll go up to here. There we are. And we'll start it off in the centre and go up to there. We can now measure that arc using the angle measurer, because we now want to divide all this up. First we'll just drag this out. There we are, so we've got that and that one over that side. And then we can also delete that. No, I might as well delete that as well actually. And that and that. Keep it neat and tidy. So now we want to work out the divisions. So on this gauge it's got 1, 2, 3, 4, 5, each one divided by 1, 2, 3, 4, 5. If memory serves, that should be 25. So we have to do some maths. We have to get the dear little calculator on this lovely old laptop and go 114.875 divided by 25 equals 4 point, let's copy that, edit, copy, handy. Now what I want to do, basically I want to divide up this top one into lots of little bits. So I'm going to delete that. I just want this little bit here, and I'm going to do that. And now there's a tool here that allows you to rotate and do as many copies as you want. And I'm going to make sure that I remember to put minus because I want it to go clockwise. Yes. Tell it where the centre is. There we are. So it's done all those divisions, so that's nice. Then we want to make a bigger division to represent 0, 10, 20, 30, 40, 50 volts in this case. So we want one that comes down. This is why I drew this bottom line. So we're going to get this one, and we're going to do the same. It's going to overwrite existing lines, but it really doesn't matter. We don't need that. Well, actually, I'll keep that just in case I forget. So we want this line, and we want to make it thicker. So I'm going to go to line, thick. Not that thick though. I think that's about 0.7, I should think. That's a guess. That looks about right. So we're going to need that copied. So now we want to repeat that, and to work out how many degrees, because my brain is a muscle, 0.875 divided by 5 equals 22.975. Let's copy that. So we've selected that. We're going to use the same tool again, paste in that, use this. We don't want 24 repeats, we want 5 of them. And we'll tell it where the centre is. There we have it. So that was pretty painless. As I say, there are far more complicated tools and methods and things, but this just works for me. Because I forgot to delete the original thin lines underneath, they still exist. And that doesn't matter at all if you're going to print this, the gauges, but if you're going to laser cut, it does. So let's just delete those before we forget. So I'm just going to select each of these shapes. I know they're not as long as the originals, and I'm going to press delete. What a fool I've been. As I say, if you want to print these, it's great, but if you want to send it to a laser cutter or something, it will see them as an additional line and cut them all out twice. That must be, oh, that's the one I changed. Lovely, let's get on with it. So now what we're going to do, we can get rid of that, we can get rid of that, we can get rid of that. And if you look at the original dial, these lines are thicker as well, the top one and this one. So let's make them, in addition, 0.7. I think 0.7 is a bit thick actually. I think 0.5 might be better. Yes, 0.5. So that's nice, and we can get rid of that as well because we only needed that to work out how much lower that comes. So now we're going to come to do the numbers. Now the bottom of the numbers, very accurate. That's 1.25. 1.25 above. Let's put that to 1.25 above the top part of here, so that we can click that on. There we are. Now we're going to draw another circle. We now don't need to know the radius, we just want it to be like that. Now this is the one that we're going to use to draw the letters on, because 2D Design does have a tool to do that. But I want it to cut off that bit so it knows if I align it left, it knows where left is. Otherwise there isn't a left, because it goes round and round and round. Now I know the next bit will be extremely upsetting to a lot of people, because there are lots of very clever tools to do this, but I found this is by far the simplest way with this sort of thing, because these tools are quite limited. I'm going to put 10, 20, 30, 40. That's a little bit big possibly. I think we might take the size down. Now these numbers are 2.8 millimeters high. Let's go to settings and go to 2.8. Okay, see what that does. That's not quite right. We need to go to settings and we need to go to position. We don't want it to calculate to stretch it, we want actual size of letters. See what that does. That's better. So now what we can do, and this is going to make your skin crawl if you're into design and things, but as I say, this is the quickest way that I've found to do this sort of thing, because you don't do that and then you think, well, I'll just take a little bit off there, possibly that much, and a space before that. Look at that. I mean, that took me not very long at all, but it works. Now we need to have a 0 and a 50. These two are horizontal numbers, so we'll go back to the horizontal. We'll get rid of the jump to click thing, and we'll go to null. That's it. And then we can position that. Where have they put it? They put it sort of down here. And then we'll copy that and we'll go to 50. There we are. And then we can put that roughly there. Where have they've put it about there actually. Then what we can do is to align. Let's do the bottoms. Align that with the bottom of that. And then we just need to slide, if I click on this, which stops you from going anywhere except horizontal sort of, we can put that there, and that's fine. And we can delete that line. Now we just need the big V in the middle. You could of course put the text on a circle. You could draw one down here, which I've used lots of times, and put voltage on it or something, which is a little bit more ornate. As I said before, if you delete those two, it knows where its left and right is, so to speak. So let's say that, put voltage. In fact, that's a bit bigger. I think that's about 4. And then we have to tell it, and unfortunately, you can't set too many of these things at once, so we go to position it, it forgets. It's quite a quirky software, but I don't mind. And now we're going to centre that actually this time. Alignment centred. There we are. So you could do it like that, or if you wanted to, you could do it like they've done it, which is just to have a big V. Let's have a big V. V. Settings 5 or 4. And we'll centre that. Possibly move it up a little bit. Then we can delete this line and that. And voila! You have your gauge. It's much more fun when you're creating your own gauges. Once you've got the radius, where you know the centre of the moving coil part of the meter, you can make things, everything you can base on that point. So you can make things larger, smaller, and change text fonts and all sorts of stuff. Oh, and people do regularly ask me what font I use. It's called Maleficio. So let's change this to Maleficio. In fact, I'll change that and just write voltage so you get a better idea. O-L-T-A-G-E. Spelling is not my strong point. Centre that. The strange thing about Maleficio is that, let's type that in, is it doesn't have lowercase and it doesn't have any special characters. But I just like the look of it. I searched high and low for fonts when I started designing steampunk machines, and I just really liked it. It was a bit quirky. There are an awful lot of fonts to choose from. The only thing is that obviously with fonts they all have slightly different sizes, widths. So anyway, you get the idea. So now we've got the design finished, we can do two things with it. We can either export it as a bitmap file, such as a JPEG or a GIF, in which case we can then send it through to a printer, and that's where the vector graphics of the original design on the CAD software is converted into lots and lots of little coloured dots. Thousands or millions of them to build up the picture, a bit like a TV screen. The problem with that is you can't run a laser cutter off it, and you can't really enlarge it or reduce it very much because it'll just lose quality. So the second option is to export it as a DXF file, which is a standard, an international standard for CAD software. And that's brilliant because that saves it as a vector file where every single line it just sees as a start point and a stop point, basically, with some other properties of the line as well. It doesn't actually see it as a line, just a start and stop point, possibly with a circle as a centre as well. That's what we need to control a laser cutter. Let's prepare our drawing. So what the laser cutter engraver needs to know is what to do with these lines. Now if we just sent it these all in black, it would just cut the whole lot out and it would look absolutely ridiculous, I tell you. So the way I usually do it is to have black as the cutting line. So we're going to leave the outside as black. Then we're going to group together the letters and the numbers because we don't want them cut out. We're going to get the laser cutter to treat them as something to be raster engraved. That means the laser's going to go backwards and forwards very, very fast and moving down ever so slowly, switching on and off as and when it's required. And that's great because that means you get extremely high quality. One thing is, we don't need them to be filled. Hang on, I can't remember what buttons I'm pressing. We don't want them filled, so no fill. And obviously we want them a different line colour because that's how you tell the laser cutter engraver, same thing really, what you want it to do. So let's make the colour a pleasant green. There we are. And then when I load it into the software that controls the laser cutter, I can tell it black line cut, green line laser engrave. Great. Now what are we going to do with this then? Because the thing is, the laser cutter doesn't care how thick we've drawn these lines. In fact, to give you an idea of what the laser cutter would do if we just sent it this bit, the laser beam is 0.25 millimeters. So if we go to 0.25, that's what the laser cutter will cut, which is great for these little middle bits, but it's not good for these bits which we want thicker, or these two bits which you want thicker. So what I'm going to do is I'm going to group them together, and I'm going to show you a trick, another top tip. And then I'm going to move them off to one side. Now, lots of CAD software, including this one, has the ability to draw things on different layers, but I can't get it to work properly. It's probably me. And any who, like I say, I learnt on big sheets of tracing paper with one layer. So we'll do it like this. This is okay. So the trick is to use the contour tool, which is this one. I've discovered that 0.1 millimeters is perfect for this, and the number of contours is 1. Basically it means it'll draw a line all around the outside of these 0.1 millimeters away. It's very handy because what it means is we can make it wider. Look, it's wider. I'll make the insides a little bit wider. I might go around the outside a bit. I think that's more like it. And we'll move that, centre it back over the rest of it. Right, and then obviously lastly, because it'll try and cut this out, we want to change the colour, and I usually use, my preference is red for line engrave. Now let's talk about engraving laminate that we're going to be cutting this out of. So this is engraving laminate. I get it in 300 by 600 millimeter sheets. It's made up of a thicker back bit, which is about 1.5 millimeters thick, and a very thin layer of another colour on top. I always like using white on black because it means the lettering or the text graphics always comes out as black. But you can equally get it in any sorts of colour, a huge range of colours and metallic and all sorts of things, black and white, whatever you want. The idea being that the laser cutter will cut off or cut away the white bit and leave the substrate underneath to show. Let's do that now. So what we'll do is to export that file, export as a DXF file, and we'll put it into a pen drive because obviously Microsoft stopped supporting this lovely old laptop and I can't redo it. I have one called AAA, yes, into which I save everything. Save that. Yes, I want to replace it. Yes, I want to use the ARC command, which I think represents circles as single items rather than thousands or hundreds of separate short straight lines. Now we'll take the pen drive over to the computer that controls the laser cutter. We'll plug it in. Another computer that I can't actually connect to the internet. It's XP, but it works and it's a joy. And it runs the software that controls the laser cutter, which is this. So I'm going to import it because it's not its native file type. Now what we need to do, there's a special tool called Unite Lines. And what it does is it checks for things such as open areas that are for engraving, and make sure that it puts things to be cut inside other things that are going to be cut later, and make sure there's no gaps in lines. It's very handy. So now what we need to do is to set up these three colours. It's seen that there's three different colours. Let's do that. So, consulting my lovely list, this is the modern engraving laminate because it does vary and it'll tell us the numbers. Let's put them in. So I've input the numbers. The engrave is an option just here, and that's got all sorts of complicated settings which I don't understand but work. But that goes at 200 millimeters a second and a power of 25%. This one, the line cut, 100 millimeters a second, the power is 16%, and the corner power, where you want it to slow down a bit or have less power as it turns corners, is 12%. And finally, cutting out this engraving laminate, 20% at 40% power, sorry, 20 millimeters a second, 40% power, 20% corner. Now we don't want it to do the black first, the cutting. We want to move these up, or conversely that's down. I want it arranged more like that, so it's going to do raster engraving, line cut, and then cut it out. Let's get some laser engraving laminates on the machine. Here's the machine. Let's switch it on. Because the limit switches are broken, I have to press the stop button. Let's put the laser engraving laminate on the machine. Because it's got a ridge around the edge, I'm going to put a washer in the middle just to make sure it doesn't sort of sink down, because we want it completely flat. Now what we need to do is to move the laser head over a fresh piece of material and use the focusing stick, which I've always used this ruler, 78 millimeters. You put it here, and then on this particular laser cutter, the whole of the bed where the material is sitting goes up and down. So you raise or lower that until it's perfectly focused. Then you can move the laser head back to a clear piece of the engraving laminate and shut the lid so it all goes nice and quiet. So let's download it. Delete all, download current. It's going to, what it's doing now, it's going to turn that design into G codes from the DXF file, which the laser cutter can read. They basically tell the laser head where each line starts, where it stops, and what power, and it's just a huge list. Go-to codes, I believe G stands for. We're going to press the test button just to make sure that we've got enough space for it, and then we're going to press start. And this is the raster engraving. By the way, the noises that you can hear that the laser cutter makes are produced by the big blower that sucks the fumes away and blows them outside. A lovely little air compressor or air pump that blows air through the cutting nozzle to stop smoke getting up and making it dirty. And coincidentally, there's the tank for the cooling water in the back. It's just a container, storage container with a pond pump in it that circulates water through the laser tube. So now what we need to do is to use some isopropyl alcohol to clean the soot off. Can you see that? Yes. And also to clean the edges as well, because where it cuts right through the back bit, you get quite a lot of soot, which you can then spread back onto the front. A little bit of judicial wiping, and you have your finished gauge legend. There, thank you. Let's talk about how you can scan one of these, an image of this in, and sort of base your drawing on that. So there's a lovely Epson scan dialog. there's the gauge, just on a preview of it, so that's it, and I've set it to 300 dots an inch grayscale. So let's get that scanned. Here's the wonderful scanner printer, the Epson ET2750. It's absolutely brilliant because it takes ink like this. These big bottles, you buy them in sets of four, the four normal colours. But it's sort of, I think I remember about 45 pounds. And they are huge containers for a set. And then you tip them upside down and very cleverly they fill up these reservoirs down here. You can see the black's running a little bit low. But you get thousands, tens of thousands of prints from one lot of these, rather than some ridiculous 45-pound titchy little mini bubble jet cartridge. It is a bubble jet printer, but it's wonderful. There we are, let's get the dial off. As with most CAD software, you can import bitmaps. The thing is, it's very important to get it the right size, so I'm going to specify that I did scan it in at 300 dots per inch. And there we have it. Let's zoom in so we can have a closer look. The other thing that most CAD software has is the ability to work with layers. That means that I could put this in one layer, create a new layer with room for me to add graphics, take measurements. However, I've never been able to work out the layer system with this software. Now, to start taking measurements from this, because obviously it's a bitmap image, I'm going to use this tool to click on 3 points to draw an arc. Now I've actually got a vector arc on it. I can use this tool, the dimension tool, to click on that line I've drawn. There we are. It'll tell me the radius and also, more importantly, give me the actual centre of that arc. Another tool that CAD software frequently has is a tool that converts a bitmap image into a vector image. Now, modern versions work far better than this one. This is very old, but we'll give it a go anyway. I regularly try and use this and then remember why I don't usually. It's not bad, that's okay. And the great thing is that this, if I unfill it, it's very useful for taking measurements off, as you sort of get a rough idea. So I could use this tool again, except now I can jump to the nearest point. So I can create my arc far more accurately, theoretically, like that. So, you know, it's got its uses. I was just sitting down to start editing it, and I checked my comments on my previous video on YouTube, and Paul Stubbs very kindly sent me a link to Meter software, or there's a free version called Meter Basics. However, Paul said that it's only suitable for printing designs. You can't export a file as a DXF format to control a laser cutter. I'll put a link in the description, and please do let me know if you know of any other software that's really good for designing meter legends. Thanks very much for watching. I hope you found it interesting and informative, and thanks to all those people who suggested me making this video having watched the previous one. If you've got any polite suggestions for future videos, please let me know. Thanks again for watching. Hope to see you next time.